So let's look at this problem right here. It says, for each trinomial given, determine if the expressions below could be factors. Put a check by the possible factors and an X by the expressions that could not be factors. Okay, now let me tell you what it means to be a factor. Let's say I've got the number 9. Okay, well, what are the factors of 9? 1 times 9 and 3 times 3. So if I were to list all the factors of 9, they would be 1, 3, and 9. Right? And so in order for us to tell the factors of this trinomial, we've got to factor the trinomial, don't we? Okay, what do you notice in this trinomial will go into all 3 terms? 2. So let's write 2 times x squared plus 14. Oh, I messed up, didn't I? It wouldn't be 14, would it? Because I'm dividing each term by 2. Here, here, and here, right? So what would it be? 7. Let me erase this. Let's see if it'll let me. Yep. So 7x plus what? 12. And so is 2 a factor? So I can put a check right there by the 2, can't I? Because, see, I factored 2 out, so it's a factor of the original trinomial, isn't it? Now we need to factor what's inside the parentheses. What form is this in? Quadratic. So if it factors, it'll factor into 2 what? Binomials. So let's do it. Let's write our factors of 12. 1 times 12. 2 times 6. 3 times 4. Are there any other factors?
No. Or no.
I don't think so. So what times what gives me x squared?
4.
X times x gives me x squared. And then which of these factors also adds to be 7x?
4 and 3.
4 and 3 does. So I'm going to go plus 3 and plus 4. The reason I did that is positive 3 and positive 4 add up to be positive 7. And positive 3 times positive 4 gives me positive 12, doesn't it?
It does.
And so this is the completely factored form. And so my factors of the original problem, here's the original problem. My factors of it are 2, x plus 3, and x plus 4. Right, Avery? And so I checked 2, didn't I? Okay. Also, x squared plus 7x plus 12 is a factor. So I got to check it. Is x plus 4 a factor? So I'll check it. What about x plus 6? Is x plus 6 in any way a factor? No, so I'm going to put an x next to it. What about 2x plus 8? Is there any way you could get 2x plus 8 in your factors? I think you could, because 2 is a factor of it, and x plus 4 is a factor. Well, let's say I took 2 times x plus 4 and multiplied it. What would that be? It'd be 2x plus 8. So 2x plus 8 is a factor. If you can take 2 factors of something and multiply them together, that's also a factor. All right, what about x plus 3? Yep, there it is right there. What about 2x plus 6? Yeah, they took 2 times x and they got 2x, and they took 2 times 3 and they got 2x plus 6. What about 2x plus 2? There's no way I can multiply any of these factors of the original and end up with 2x plus 2, so it is not a factor. On this problem, we have 6x squared plus 6x minus 12. Before I try to write this in 2 binomials, I'm going to factor the 6 out, right? So when I factor the 6 out, I'll write 6 times what?
X squared. Plus 1.
Plus 1 what? Minus 2. Very good. So all I did was I took each term and divided by 6, because 6 would go into each term, right?
Mm-hmm.
And so that's how I got each of these. That one, and that one. And now when I look inside, I have a trinomial that's quadratic, which will usually factor into 2 what? So I've got 6 times 2 binomials, and x times x gives me x squared. And the only factors of 2 are 1 and 2, right? So what do I want how can I get a positive 1 here and a negative 2 there?
2 minus 1. 2 minus 1.
Right, 2 minus 1, so I'm going to say plus 2 minus 1. And so let's check it real quick. 2 times negative 1 is negative 2, and 2 minus 1 is 1, isn't it? Okay, so here are your factors. Now, if we were to list our factors, let me show you what we'd be listing. We'd be listing x squared plus x minus 2, it's a factor. We'd be listing 6. We'd be listing x plus 2, and we'd be listing x minus 1. And then any combination where you multiply them, you got to list your factors of 6. 6 is also 2 times 3, isn't it? So I could take 2 and multiply it by that binomial, and boom, that's a factor. Or I could take 3 and multiply it by that binomial, and that's a factor. All right, so let's look at 3. Is 3 a factor of this? 3 is a factor. Okay, because 6 is 2 times 3, isn't it? What about x plus 1? X plus 1 is not a factor. What about 2x plus 6? 2x plus 6 is a factor because if you take 3 and you multiply it by x plus 2, it gives you 2x plus 6, so that's a factor. You can take any of the factors and multiply them together, and that makes a factor. Okay? What about x minus 2? Is it a factor? No, it is not. X plus 2 is, but not x minus 2. What about 6? Is it a factor?
Yes.
Yes, good. What about 2x plus 4?
No.
Yeah, it is. Look, x plus 2, let's write x plus 2. And then is 2 a factor of 6? So what if I take 2 and distribute it to x plus 2, what do I get?
2x plus 4.
So it's a factor. If you take any of the factors and multiply them together, that's also a factor. What about 3x minus 3? It is, because you can take x minus 1 and distribute 3 into it, and you get 3x minus 3. What about 6x plus 12?
Yes.
Yes, because you got 6 as a factor, and x plus 2 is a factor. If you distribute the 6, you get 6x plus 12, so it is also a factor.